Good afternoon, everyone. Hope all is well and everything is all right. Hope you had a great weekend. Everybody's doing okay. So let's see. I think for last class we did chapter 7. So we're looking at chapter 8 today. Where's my book? Hold on one
After
second.
class, can I ask you some questions on the homework?
Never. Yeah, not a
Oh,
problem.
okay, sweet.
Give me 1 second. All right, so let's look at chapter 8. Chapter 8 is a little more wordy, so I actually wrote these notes on a piece of, not piece, well, yes, on paper. So let me pull those up. Then I'll magnify them accordingly. So 8.1, distribution of the sample mean. Let's see, let's get out of the way. All right, so the sampling distribution of a statistic is a probability distribution for all possible values of a statistic computed from a sample size of n. All right. So the sampling distribution of the sample mean x bar is the probability distribution of all possible values of the random variable x bar computed from a sample size of n from a population with mean mu standard deviation sigma. So of course, this is the background stuff. We'll talk about what this means in a second. Scroll up. So we're done with the first one. All right. Suppose that a simple random sample size n is drawn from a population with mean mu and standard deviation sigma. The sampling distribution of x bar has the mean. Let me see, can I write on this while it's like this? No, I can't. All right. So notice our mean is going to be the mean of our population. And then the standard deviation, we would take the standard deviation of the population and divide it by the square root of our sample size. So as always, once you put numbers on it, we'll be able to make those connections a little bit easier. These are the words and the symbols behind that. right, scrolling up. Of course, if I scroll up and you still copying, let me know. Standard deviation of the sampling distribution of X bar is called the standard error of the mean. Similar to what we referenced last class with the standard error. All right, last statement for this page. If a random variable X is normally distributed, the sampling distribution of the sample mean X bar is normally distributed as well. So see what I have there in red? This means that we can use the Z-scores, and that's what a lot of this is going to depend on, the fact that these things are normally distributed. So we can use our Z-scores, our Z-score relationship.
Professor, before we go to the next page, could you zoom out on this one so I could quickly take a snippet of it?
Yep. Not a problem. Let me see, is that, if I go here, can anybody, is everybody okay with that? All right,
Got it, thank you.
not a problem. Anybody still copying? Everybody okay?
Okay.
Okay. Let me see. All right, let me close out this other page so I don't get it messed up. Oh. All right, trying to get this pen off. There we go. All right, so let's look at a first example. Look at trying to apply these relationships with these numbers. So the IQ, called net X of humans, is approximately normally distributed with mean 100, standard deviation of 15. Compute the probability that a simple random sample of size n equal to 10 results in a sample mean greater than 110. All right. So first thing we always want to do whenever dealing with a word problem is always focus or pull out your given information. All right, and that's what I have over here in the box. I can't write on the screen when I have it magnified like this, but that's what I have over here in the box. That's the given information. Our mean is 100. Standard deviation is 15. Sample size is 10. And then the data value in question is our 110. We're talking about being greater than, or our mean being greater than 110. So I give you a chance to finish writing that out, word problem and such. All right. So now if you go back to your notes when we were talking about how we determine what our mean will be and our standard deviation of our sampling distribution, the mean of our sampling distribution is the same as the mean of our population. That's why it's going to be equal to 100. And then our standard deviation is going to be the standard deviation, population standard deviation divided by the square root of 10. So if I can go out a little bit, just so I can write on the screen. So I'm talking about this relationship right here. Our mean is going to be the mean of the population. So that's 100. And then we can calculate our standard deviation right here by taking our 15, which is the standard deviation of our population, divided by the square root of 10, which is the square root of our sample size. All right, so any questions on this part right here? All right. So from there, oh, I gotta close it out. There we go. So from there, we can find our z-scores, or z-score, not z-scores, but z-score. Notice the formula right here, x bar minus the mean of our sampling distribution divided by the standard deviation of our sampling distribution.
I'm sorry.
That's-
Could you
Hmm?
zoom out a little?
All right. Well, let me ask you guys this. I mean, can you guys see it at this? I mean, because I was magnifying it, but if you know, if you guys can see it well like this, you know,
I can see it good like that.
okay. Well, I'll keep leaving it like this, guys, and then if anybody need me to magnify it, then let me know. You know, I'm fine with that.
In part one, where you did the mean of the population is 100, is it always going to be simple like that? Like it's just going to come from the word problem? There's gonna be-
Yes.
Okay.
Yep. Yep. Glad you asked. This will always be the case. Whatever the mean of your population is, that's going to be the mean of your sampling distribution. And then the calculation will come right here, though, the first part of your calculation, when you want to establish your standard deviation of your sampling distribution. All right. Everybody all right? So don't forget, whenever you calculate your z-scores, you round to 2 decimal places. So that's why we have 2.11. Once you have your z-score, we go to the chart and we end up getting 0.9826 from the chart. And we talked about last class how to read the chart. Yep. Remember, you have 2.1 right here and then 0.1 right here, 0.01. And where they meet in the chart will be the chart value. All right. And so don't forget that your chart value will always be less than. Chart value will always be less than. So that's what I was notating there. But if we want greater than, which is what the chart, this problem was asking us, then we're going to subtract that from 1. And so our answer right here is going to be at 0.0174. All right. Once again, if it said sample mean less than, then we would have just taken the chart value. But since it asked for greater than, you subtract your chart value from 1. And that, remember, all that was established back in chapter 7.2, when we talked about our different scenarios. So conclusion, the probability of obtaining a sample mean IQ greater than 110 from a population whose mean is 100 is 0.0174. I'll give you guys a chance to finish. All right, is anybody still copying? All right. Let's see if we can go to the next one. It's not gonna let me, I gotta go out. All right, hold on 1 second. All right, so here's the third page. I wonder why it won't let me go to the next page, but I don't know if some weird happening. Anyway, it's all good. So third page of our notes, the central limit theorem. Says regardless of the shape of the underlying population, the sampling distribution of X bar becomes approximately normal. Remember, that's key. If it's approximately normal, that allows us to use our z-scores as the sample size n increases. So it becomes approximately normal if you increase your sample size. So in other words, that's just saying that if your population's distribution is not approximately normal, if you increase your sample size, it will become, your sample size will be, and that's what we're analyzing. So if the distribution of the population is unknown or not normal, then the distribution of the sample mean is approximately normal, provided that the sample size is greater than or equal to 30. So we would be looking for a sample size that's greater than or equal to 30 if our population is something other than approximately normal. So the last example, we only used 10 as a sample size. That was okay because our population was approximately normal. Here, if you look at this next example, our population is going to be skewed right. So we're going to need a population, not a population, we're going to need a sample size that's 30 or greater in order to be able to apply what we did in the last problem. So we look at this example, it says the mean weight gain during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. Weight gain during pregnancy is skewed right. So that's letting us know that our population is not going to be approximately normal. An obstetrician obtains a random sample of 35 low-income patients and determined their mean weight gain during pregnancy was 36.2 pounds. Does this result suggest anything unusual? So I'll give you guys a chance to write that down. I think we still have writers, correct? I know, see one person, okay. All right, take your time, just making sure. All right, are we good now? I see one head nod. Anybody else before we go to the next page? So now,
Okay.
all right, sounds good. Thank you, thank you. So now what we're gonna do is go ahead and do this problem right here. I don't know why it will not let me just, there we go. All right, cool, there we go. So here's the given information right here. And then you know how I do it, I put it in a little box. Our mean was 30, standard deviation was 12.9, sample size is 35, and the data value in question, what were we asking again? Mean weight during pregnancy was 36.2, so our data value in question is 36.2. All right, so just like before, right here, our mean is going to be the population mean, so we're using that 30. All right, so no calculation there. So our first piece of calculation comes into play when we look at trying to calculate our sample, standard deviation of our sample and distribution. So we take our 12.9 divided by the square root of 35. That's what we have. And of course, if MyMathLab asks you for it, they'll let you know how many decimal places you need to round out to. Then here, convert it to a z-score. Convert our 36.2 to a z-score. gives us 2.84. Once again, once you have the z-score, you go to the chart. So 2.84 will yield 0.9977. And always remember that represents less than. So before we go to any conclusions, any of my sentences that I've written, do anybody have any problems with what we've done? Make sure we're all right. All right, so the first statement I have here, after you've been to the chart, since we want to know how unusual this is, then we want to know the chance of being greater than. All right, so once again, if we were just dealing with less than, we would take the chart value, but we want to know the chance of greater than, so we're going to subtract it from 1, and we get 0.0023. So this is unusual because the probability is going to be less than that point, or that 5%, which is 0.05. And I think, yeah, that's all they asked on this was whether it was unusual or not. Yeah, but conclusions you can come up with as to why this has occurred. It did say that the doctor pulled from low income patients. Like the people that he chose just so happened to be, this unusual category, or the main weight for low income patients could be, more than 30 pounds. And then you can start talking about, well, why is that the case if you go with that one? Could it be diet? Could it be availability to certain things? All the different type of things. So that's what this, statistics would do. It would start to guide you into different places and guide you into different questions in your research to try to establish why certain things are occurring. So yeah. All right, anybody need this? Can we go to the next page? Next page. All right. Close this out. There we go. All right, try this thing, go here. 3, 4, just make sure my pages are straight. 3, 4, and then we're right here. So if I'm not mistaken, yep, that was it for 8.1 as far as examples and what they want you to focus on. Now this is 8.2. It's going to fall along the same lines, so the flow is going to be very similar. Just adding another symbol here, and we're going to start talking about, instead of talking about your sampling distribution, here we're talking about the sampling proportion. So just a few different terminology, but the flow is going to be exactly the same. You see what I mean in a second. So on title of this section, distribution of the sample proportion. So suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion is given by p hat, that part of a triangle, or a triangle without a third side is considered a hat. So that's p hat, and you'll calculate that by doing x over n, where x is the number of individuals that has a certain characteristic. And then n, of course, is your sample size. And here's sample proportion, is a statistic that estimates the population proportion. So whenever you see p versus p hat, p is your population proportion, and then p hat is your sample proportion. All right, how we looking with this page? We good to go? Body straight. All right. Let's see, 1, 2, yep. All right, so here, computing a sample proportion. Have the Harris Poll conducted a survey of 1,200 adult Americans who vacation during the summer and asked whether the individuals plan to work while on summer vacation. Of those surveyed, 552 indicated that they plan to work on vacation. Find the sample proportion of individuals surveyed who plan to work while on vacation. So now this is not a full example. This is just us establishing how you would find the sample proportion if you were trying to look for it. So N is the number of people surveyed. That's 1,200. Says surveyed was 1,200. So that's our sample size. And then X is the number of people who takes on the characteristic that we're discussing, which is those who plan on working on summer vacation. So that's 552. So if you want to calculate P hat, you would just do 552 over 1,200, which is 0.46. So basically the Harris Poll estimates that 0.46 or 46% of adult Americans who vacation during the summer plan to work while on vacation. So that's just basically how you would calculate your sample proportion. All right, anybody still copying? All right. So here we have the sampling distribution of P hat. So for a simple random sample of size N, the population proportion with a population proportion P, the shape of the sampling distribution of P hat is approximately normal, provided that we have this initial condition right here. N times P times 1 minus P has to be greater than or equal to 10. And the reason why that is important, once again, we're talking about being able to use Z-scores. So this initial condition has to be in play in order for it to be approximately normal. So once that's been established, then that means that we'll be able to use these scores in the same fashion that we did last few problems. Well, basically since chapter 7. And then it says the mean of our sampling distribution is going to be whatever the population proportion is. So same thing that we did in 8.1. So whatever the population proportion is, that's going to be our mean. And then here to calculate the standard deviation, we're gonna do P times 1 minus P over N and take the square root of that. All right, so looking at the problem at the bottom, it says according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. Kind of ran that down there. I might need to magnify it. Let me know if I need to or not. I know I can see it, but I know my own handwriting. So in a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? Suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. What might you conclude? All right, next page. Anybody still copying? Still copying?
I'm still copying a little.
Okay, not a problem.
I just took a picture of it. You can move on.
Okay, okay, not a problem. Anybody else? Everybody good? Let's go to next. All right, so let's look at, let's even go back to what we're at. Okay. All right, so first thing we want to establish, just in case my math lab were to ask you, is the sampling distribution approximately normal? So this is the part right here. Where's my tools? Right here. First thing we look at, what is N, what is P? So our population proportion was 15%. If you were to go back here, it says approximately 15% of all Americans. So that's your population proportion. All right. So we take our population proportion, multiply times 120, and then 1 minus that population proportion, which is 0.15. Notice that gives us 15.3, and that is greater than 10. So that's what this statement right here is. So since 15.3 is greater than or equal to 10, the sampling distribution is approximately normal, and that means we can use our Z-score application. So make sure we're okay before we go to the blue. So we'll make sure we're okay with the red. All right, so looking at A, it says in a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? So they give us our our sample proportion, say at most 12%. So that's what we're looking at there. And then the mean of our our sampling proportion is going to be whatever our population was. So remember that was 15%. So that's why we have that being, that being 0.15. And then we have to calculate our standard deviation of our sampling proportion or sample proportion. And I made a little mistake right here with that, this over the end, that's not supposed to be there. But so that's P times 1 minus P over the square over 120. So I was made a mistake again, but doing that, and that gives us this right here. All right. So we're going to convert it to a Z-score, and we see that right here. And how we would do that, P hat minus the sample proportion mean over the standard deviation of a sample proportion. So it's 0.12 minus 0.15 over 0.032596, and that gives us the Z-score of negative 0.92. All right, so going to the chart, that gives us 0.1788. And once again, remember, just a note that whatever we get from the chart is always going to be less than, always represent what's less than the value in question. So in the red, it's helping us to get there. It says, since the question asks at most, this means we want less than. So the chart value is going to be answered. So if something is at most, so at the most, we're looking at this value. So that's that number and everything less than it. So if it said at least, then that would be that number and everything greater than it. So at most, that number, everything less than it. If it's at least, it's that number and everything greater than it. So we're going to use the chart value. And so the probability that the random sample of 120 Americans result in at most 12% having hearing trouble is 0.1788. All right, anybody still copying? All right, I think this is, okay, yeah. All right, so let's look at B. So this time, looking at B, it says, suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing trouble. What might you include? So this time they didn't give us P hat. If you go to the one previous, they gave us P hat. They told us 12%. This time they gave us the number, which is 26. And that's 26 out of the 120. So we went ahead and found P hat right here, 26 out of the 120, which is, come on, erase, which is going to be that 0.217. So problem didn't change. So our mean is still the same. And our standard deviation is still going to be the same. Just that they gave us a different P hat to have to consider. From there's Z-score formula. So that's 0.217 minus 0.15 divided by that standard deviation. All right, so our Z-score 2.06 gives us 0.9803 from the chart. And so my red statement right here, since the question asks what might you conclude, we should explore greater than to see how unusual it is. Remember we talked about being unusual before. We want to see greater than to examine that. So greater than is always 1 minus the chart value. So that gives us 0.0197. So the proportion is less than 5%. So this means it is unusual occurrence. And we go back to reading, it says, we're talking about earphones. Okay, yeah, so it's unusual. So once again, whenever you get these, this information, let me see if I put it in the next one. Oh, do that. Might be in the next. Yeah, okay. Anyway, I'll let you finish that. Then I'll tell you, we'll talk about the conclusion. I got it on the next sheet. All right, anybody still holding on to this page? All right, so last page of notes. So since it is unusual, we can make one of two conclusions. The population proportion of Americans with hearing trouble who regularly listen to music using headphones is 0.15, and we just so happen to randomly select a higher proportion that have hearing trouble. So in other words, even though the population is what it is, we just so happen to choose a bunch of people that have hearing trouble, or the population proportion of Americans with hearing trouble who regularly listen to music with headphones is more than 15%. So in other words, the people who use headphones will have a higher chance of having hearing trouble because they use them regularly. And so what's more, more reasonable is the second one, is that the headphones, the regularly listening to headphones contribute to hearing trouble. Oh no, what's happening? Okay. Any questions on anything? Any questions on anything? All right, so that's it for chapter 8. The main thing now is for you guys to get in there and try the stuff out. See if you have any questions and see if there's anything I can do to help you out as far as making sure that there's clarity on what we're doing for this section or this chapter. Wednesday, we will not have class. I have to go out of town. So, always feel free to shoot me that email if you have a question. But we really won't meet again until next Monday. Next Monday, I have to go out of town. So, I know Ms. Andrich has questions, but any general questions before we close out? I mean, because you don't have to stay back for her questions. If you're good to go, you're good to go. But feel free to do so. But any questions on anything before we look at what she has going on?
So we don't have class on the 14th, but we'll resume class on the 19th.
Sorry, I had a sneeze and then it went back up. But yeah, let me look at those dates and make sure that we straight. So the 14th, right? We do not have class on the 14th. The 19th will be when we come back. Yep.
When
Okay.
will the next test open?
Let me see. So chapter 7, chapter 8, and really I can go ahead and post that now because I believe I told you guys I wouldn't be doing a proctor one except for the last one. So I can go ahead and open it up before the day is out, just so you have access to it for anybody who just want to go ahead and jump in there and knock it out. But yep. And if I'm not mistaken, I'll check to confirm the next test that we will have will be the proctor test. It will not be any more other than what we have. So yep. Anything else? Anybody else? All right. So if you want to stay back for questions, feel free to do so. If not, because these were math questions, right? It's not okay. Yeah, if you want to stay back for questions, feel free to do so. If not, then I will see you guys next Monday. Have a great week.
Thank you. Bye.
Not a problem. Thank you. Have a good one.
Professor, I have
Yes.
a question. It's not a math question, but
Mhm.
just probably one you can or cannot answer.
Mhm.
How bad can a test take you down?
It depends on how your other tests, how your other tests were. Because I'm doing an average. So, if you had now the worst thing you can do is not do a test at all, because that's a zero,
Yeah, of course.
So, if you have A's on everything else, but then you have a 60, that's not the worst thing in the world. You know what I mean? So it just depends on what your other tests are and then how low that one is. So if you have a question like that you want me to evaluate where you are, where you stand, you can feel free to shoot me an email. I can let you know what I see and where you stand and stuff like that.
Okay.
Yeah.
Thank you.
Yep, not a problem. Not a problem. All right. So Miss Andrich, what you got?
Yeah, 7.2 is not my friend. So the first one is number 3. It gives you z minus 1 and then like z1, and it wants you to get the combined area. And
Okay.
the example was not helpful.
Gotcha. And it just kicked me out of my math lab. Give me a second so I can get back in there. And you said 7.2, number 3, right?
Yeah,
Yeah.
there's like 4 of them. I just
Not a problem. There we go.
and I went and checked. These ones are on your review. So
Okay. So we got to make sure we get clarity on these then. So I'd like to show you what I see to make sure that we're seeing the same thing. So we said number 3, area on the curve is -1, and area to the right is 1, combined area. Okay. So now, well, I guess I'll do these and then you can apply it to what you got going on. So this one, we're looking at a z-score being -1, +1. We want the area to the left of -1, area to the right of +1. So that's what we're looking at for this one. So first z-score called z1, -1.00. So when I go to the chart, I'm looking for -1.0 over here, 0.00 up here. And then where they meet is what I'm going to use. All right. Just want to make sure we are clear. All right, so we're looking at -1.0. So -1, where's my pen? All right. So -1.0 is right here. 0, 0 is right here. So we're looking at this part, 0.1587. All right. And I might as well go ahead to 1.0. And then positive 1.0 is right here. And we're looking at positive, so that's 8413. All right, so let's go back to the notes. So now the chart gives us 0.1587 here. And then for 1.0, if I remember correctly, 8403. I gotta go back.
1.3.
1.3. All right, cool. Thank you. All right. So now we're talking about to the left of -1.0. So this is fine because remember the chart always gives us what's to the left of. But then we're talking about to the right of this value. So we actually have to do 1 minus 0.8413, which should be the same thing. 1.48759. Yep. So we're going to add these two values together. I'll turn that green. Four, 7. So it should be 3174. Yeah, that's all they wanted. All right, so was that okay?
Yep.
Okay. So
It's
now
just
did you
the-
want, huh?
Yeah, can you do the next one is the same thing, it's just different numbers?
Okay, okay.
I think so.
Yes. So I got negative 1.56 and then negative 2.56. So we're looking at to the left of negative 1 point and then to the right. Yep. So same process.
Okay. Yeah, I
And,
didn't realize they subtracted 1 from 1 because I kept doing it to both and then it wasn't working.
Oh yeah, yeah. So keywords, those key phrases, left of, right of, will mean all the world to you as far as what you will do and what you wouldn't do. So left of, you're gonna use the chart value. Right of, you're gonna take the chart value, subtract it from 1. Yeah. So did you still want to do B?
No, I got it now.
Okay. Okay. Cool. right.
Number 4.
Okay. So z-score such that the area under the standard curve is point. All right, so this one, find the z-score. Yep. So this one we're actually working in reverse a little bit. They didn't give us an example of this one, but I always I look to somebody that asked me the question, so it never fails. So that's a good thing. So this time we have the area under the curve is 0.52, and we want the z-score that corresponds to that. So we're actually working in reverse. So we want to go in the chart, find closest value.
Are you trying to stay below it or are you trying?
It doesn't matter. Just
Okay.
the closest one. That's a good question as well. Closest one, whether it's above or below, whatever's the closest value to that 0.52. So 0.5, let's see, 5.3. So I see 0.5199 right up here. So that's 0.05. So so I saw 0.5199. It's closest one. It's 0.05, and this is 0.0 up here. All right, so let's make sure my math letters all they wanted. All right, I just these. Okay. Yep, that's all they wanted. So going back to that problem, showing you that. So if they give you the area,
Mhm.
then you know they want you to find the z-score. So you go inside the chart and then find the corresponding
Okay.
z-scores to it.
I just have 2 more. I have number
Okay.
5
Mhm.
and then I might have lied. I might have 12 and 13. But
So here, find the z-scores that separate the middle 78% of the distribution. Okay, not a problem. So we have our z-score, and we know 78% of our data is in the middle. So we need to take that and do 1 minus 0.78 and then divide that by 2. So that's 22. And that means that if that's 0.22, that means, whoa, I'm going to have 0.11 over here and 0.11 over here because it's the middle 78%. And we want the z-score or z-scores that correspond to both of those data values that, split up your data in this fashion. All right. So, excuse me. So we're going to go back to the chart. and look for the closest thing to 0.11. All right, could you hold on 1 second?
Yep, you're fine.
All right, sorry about that. My daughter stuck in her high chair, had to get her out. So let's see. So we're looking for 0.11. Let's see. I see 115111. Okay, so here's where our two values. So we look at these two values and see which one is closest. So that would be to me the 1093, because this is 0.0012 from it. This is 0.007 from it. So that would be the one that we would use. So that would correspond to negative 1.23. Okay. All right. Negative 1.23. So this value is negative 1.23. And since it's symmetric, whatever's going on over here is going on the right side as well. So that should be positive 1.23. So that's how it should work. All right, so let's see what my math lab does for us. Negative 0.23, separate by a comma. Yep, that's all they wanted for that one. All right, okay, so after that one, which one are we looking at?
I think it's number 12.
Okay,
Number 12, part B. For some reason, I couldn't get.
okay, not a problem. So steel rods manufactured at 23, with the mean 23. Standard deviation of 0.06, which is probably less than, okay. So you say you're good with A, so I'm gonna just throw something in there just to get the B. All right, any rods that are shorter than 22.88 or longer than 23 are discarded. What proportion will be discarded? Okay, so we need to convert both of those to Z-scores. And then you remember how we did with the 1 and the -1? So get the area from one, area for the other, and then add them together.
Okay.
Yep. So let me take a picture of this. So I don't have to keep going back to the notes. Let me go back to the problem. All right, so we got our mean is 23. Standard deviation is 0.06. First data value, 22.88. Second value, 23.12. So we want less than this value and then greater than this value. I know it's kind of sloppy, but yeah. So find the first z-score, 22.88 minus 23 over the 0.06. It was 0.06, yeah. And then the second z-score is going to be 23.12 minus 23 over that 0.06. So this is negative 0.200. The other one might be the same, but positive.
Yeah, mine were the same, just one was
Mhm.
negative, one was positive.
Mhm. So that's good because that means you only have to find one of them. So you just find this one, the negative one, and then just like before, it's symmetric. You know, you got the same thing. So go to the z-score chart. I didn't mean to do that. Press the wrong one.
So with the one I had, it was 2.375.
Mhm.
Do I round that and keep it 2 digits? Or do I
Ye-
keep it a 7?
Yeah, it should be 2.3. You said 375. Yep. So you go 2.38.
Okay.
Uh-huh. Yep. So negative 2.0 for me is 0.0228. Yep. So 0.0228. So like I said, since both of them is just a positive negative representation of them, and I want to know what's to the right of this, that's still going to be 0.0228 as well. Can you just add those two together? Yep, so 0.456. Yep, that's all they wanted. All right. What's supposed to be 5,000 manufactured by day? How many? Okay, 5,000 times 0.0456. And then for C, yeah, you would just take that number that we got and multiply it times 5,000.
Yeah, I got the rest of that
Oh,
problem.
okay, so you're good to go. Okay.
And then 13, I got part A. I wasn't sure how to do part B.
Okay. All right. So the number of chocolate chips in a bag that make up the middle 97% of the bag is blank to blank. So we need to convert, we need the actual data values for this instead of the z-scores. So that goes back to, I don't know if I talked to you about this. Let me see if I got this in the notes already. Instead of writing it down. That's not the right one. Nope. That's interesting. All right. So our z-score formula is the data value minus the mean divided by the standard deviation. Now, if I want to take that and solve it for the data value, the actual data value, then I would multiply both sides by sigma and then add. So actually, that's just this is just a manipulation of the first formula right here. We just solved it for x.
Mhm.
And so this actually represents x as our actual data value and whatever we're talking about, the real application. So they asked us for what number of chocolate chips, that's what we're actually talking about. So once we get the z-score, we already have the mean, we already have our sigma standard deviation. Now we need the z-score. So once we get that z-score like we did before with the percentiles, then we'll plug it in here, and then we'll be able to find the data value that actually corresponds to that z-score. So, before what we did was we had a data value, converted it to a z-score.
Mhm.
So now we'll get the z-score and then convert it back to a data value. So we'll know how many chocolate chips actually correspond to that z-score. So let me see what the numbers are on that. So number of chocolate chips in the bag, we have 1262, 118. So it means 1262, sigma is 118, and our percentile, 97, middle 97%. So we're looking at it like this, and we have 0.97 in the middle. And so that's 0.3. So we're looking at 0.15. Just want to make sure on that. Excuse me. So it's going to be 0.015. 0.015. So I need to go into my chart and look for the closest thing to 0.015.
And the 0.015 you got from,
Oh, yeah, let me go back. Yeah, so you do 1 minus 0.97, because I had 97, the middle 97%.
okay.
So that's 0.03, and then divide that by 2. 0.015. Yep, sorry
Okay.
about that. And then we want to find the corresponding z-score to that 0.015 in the chart. 1.3. Oh, that's exact. I'll show you what I see. So 0.015 is actually in there. So I'm looking at negative 2.17. So it's negative 2.1 and then 0.07 up here. So that means first z-score is negative 2.17. And then my second z-score is positive 2.17, going back to our symmetry. So, if you want to go back to the chart and start, doing all the work, you can. But, since we're talking about the middle 97%, we know that whatever's over here is also over here, and all that reflects. All right, so now if I want to find the data value that corresponds to Z1, once again, we got this formula, your mean plus, I'll just rewrite it right here. So that's 1262 plus negative 2.17 times, I think it was 118. 1262, 118, yep. So I'm getting 1005.94. I'm pretty sure they're gonna tell us to round to the nearest chip, but we'll see in a second. Same thing here though, except this time we're gonna use the second z-score. 1262 plus the positive 217. And that'll be 1518.06. All right. So let's see what
Okay.
my math lab want from us. Yep, round to the nearest whole number. And so make sure you put them in the right spot, because I'll just go ahead and share it. So it says number of chocolate chips, says round to the nearest whole number, but it said also use ascending order. So in other words, and it makes sense, but sometimes if the warning isn't there, you'll just put them anywhere. They want you to go from lowest to highest as far as how they're labeling what they got going on right here. So we got 1,005, so it's gonna be 1,006. Cause that 9 and then 15, 18. And yep. That's it. All right, so you cool with B?
Yeah.
Okay. Did you have a problem with C as well?
I didn't get past B, so it won't
Okay,
let you do
okay.
C.
Okay, yeah, so now the interquartile range, that's the middle 50, so it's the same thing as B, except 50% is in the middle. And that
Okay.
means 25 is gonna be on each side. You know,
Okay. Thank you.
Yeah. Not a problem, not a problem. Glad I could help. And let me know if you have any other questions.
Okay. Thank you.
All right, take care.
I have a quick question. I'm sorry. So I saw your message this morning about the attendance and delay. I just wanted
Okay.
to let you know I'll start working on because I traveled. I came back last night, so
Okay. Okay. And if you have been doing anything up to this point, you're probably okay. It's just that I have certain individuals and I try not to point people out, but I just give a blanket statement to make sure people connect with me. But I got you down, so you'll be good to go.
thank you very much.
All right. You have a good one.